ever wondered how to find the formula for a quadratic sequence? Today I'll show you how to find their general term in simple steps. So what is a quadratic sequence? A quadratic sequence is one where the difference between consecutive terms isn't constant, but the second difference is. Let's take an example. 5, 8, 13, 20, 29. Our goal is to find the general formula for this sequence. To begin, we calculate the first difference by subtracting each term from the one after it. For this sequence, the first difference is 8 minus 5 gives us 3, 13 minus 8 gives us 5, 20 minus 13 gives us 7, and 29 minus 20 gives us 9. Next, we calculate the second difference by subtracting these results. 5 minus 3 is 2, 7 minus 5 is 2, and 9 minus 7 is also 2. Since the second difference is constant, we know this is a quadratic sequence. Here's a shortcut. Whenever the second difference is a constant, divide it by 2 to get the coefficient of the leading term, or n squared. In our case, 2 divided by 2 gives us 1, meaning our sequence will include n squared. Now let's rewrite a new sequence for n squared. The values are 1, 4, 9, 16, and 25. Let's compare these values to our original sequence. To match the sequences, we need to add 4 to every term of n squared. For instance, 1 plus 4 gives us 5, 4 plus 4 gives us 8, 9 plus 4 gives us 13, and so on. So the formula for our quadratic sequence is n squared plus 4. Let's look at another sequence. 2, 1, 2, 5, 10. Is this quadratic? We start by calculating the first difference. 1 minus 2 is negative 1, 2 minus 1 is 1, 5 minus 2 is 3, and 10 minus 5 is 5. Now for the second difference, 1 minus negative 1 gives us 2, 3 minus 1 gives us 2, and 5 minus 3 also gives us 2. Since the second difference is constant, this is a quadratic sequence. Again, divide the second difference by 2, which gives us 1, meaning our sequence starts with n squared. Now compare the original sequence with n squared, 1, 4, 9, 16, and 25. The differences between this and the original sequence are 1, negative 3, negative 7, negative 11, negative 15. This difference follows a linear pattern. Do you remember how to find the general term easily? The difference is negative 4, so it contains negative 4n. We need to add a hidden constant term, which is plus 5. When we combine n squared and negative 4n plus 5, we get the original sequence. The general term for this sequence is n squared minus 4n plus 5. Now, let's try a couple of examples together. In this sequence, 0, 2, 6, 12, 20, the first difference is 2, 4, 6, 8. And the second difference is always 2. Since the second difference is 2, it contains n squared. Now compare the original sequence with n squared. We can see that we need to subtract 1, 2, 3, 4, 5 to match the original sequence, meaning this linear sequence is negative n. So the general term for this sequence is n squared minus n. Finally, let's try a more challenging one. 1, 4, 11, 22, 37. The first difference is 3, 7, 11, 15. And the second difference is 4. Dividing by 2 gives us 2, so we start with 2n squared. Now we compare the sequence with 2n squared. 2, 8, 18, 32, 50. The differences are negative 1, negative 4, negative 7, negative 10, and negative 13. This is a linear sequence with a difference of minus 3, and the hidden constant is plus 2. So the linear part is negative 3 and plus 2, and the final formula for the quadratic sequence is 2n squared minus 3 and plus 2, and that's how you find the general term of a quadratic sequence in simple steps. Try these methods with other sequences and see what formulas you can come up with. Thanks for watching, and don't forget to like and subscribe for more math tips.